So here I've rigged everything up nicely where my slider N controls the number of rectangles drawn on the screen, but also the number of summands here following that area formula from my previous clip. So for n equals 1, I have a single rectangle of height 1.6875, and that will be my area. That area is actually too small, but if I pick more rectangles in this way, I'll get more area. So a closer value would be 1.997. And I can just let this put more and more rectangles in. Now I can't even see those rectangles because they're drawn too narrowly for me to tell the difference between the function itself. And as I go out further, right, this area is still getting a little bit bigger, but it is tending toward a limit here. So it looks like at least those first couple of decimals have settled down. And in the limit, I should be getting an amount of area about 2.044. And just to verify that that's not the exact amount of area, I can zoom in to remind myself that this really is an approximation. I can start to see those kind of sawtooth patterns. So this is a little bit less than the correct answer, but it's a pretty good approximation. Now, I could try something different. What if I had rectangles that were above instead of below? So my rectangles would need to look like this. They'd be slightly more than the value of the function. They'd match up on the left here for this problem. So I can get that by changing the formula slightly. For n equals 1, I should have a single rectangle with height 2.66. So area 2.66. When I bump up to 2 rectangles, I get a more accurate picture and a more accurate number. And as I go, I very quickly see that the area I'm approximating is much closer, and it's tending towards that same limit here, 2.044. So it looks like there's some kind of choice that I can make here, whether my rectangles are too big or too small. And that will change the calculation a little bit. But in the end, it looks like I'm approximating that same area. So this is giving me a formula the area between the x-axis and the graph of a function, f of x, on the interval a to b. We can only do this on finite intervals. Well, what should that area be? It's the limit. And in the limit, I'm calculating up the sum of the areas of different rectangles. So this will be the sigma notation again. N is going to infinity. In the sum, I'm looking at, let's say, k from 1 up to n, height of rectangle number n. But I do have a choice here. So for right now, I'll just call this x sub k. So we pick a different k depending on if we want a slightly different formula. And then what is the width of each of these rectangles? Well, it should be the same width every single time. Should be some chunk of the x-axis. For that reason, we'll call that delta